Hello, Physics Nation. My name is Nate Larmond, and I'd like to do part 2 of the AP optional student review question about car X and car Y. They have a speed of VC going around the turns, a distance D. Car X accelerates constantly for the first half of the straightaway up to 2 VC and then decelerates constantly back down to VC. But car Y accelerates more quickly up to 2 VC for the first quarter of the straightaway, maintains 2 VC, and then comes back down in the last quarter. All right, so like I said, qualitatively, you would expect the car that accelerates for the first quarter maintains that high speed and then comes down to win. So we were in the middle of the quantitative solution, and it's kind of tricky. You have to use average velocity equals distance over time and average velocity equals initial velocity plus final velocity divided by 2. I did that for one half of the straightaway, and I found the time, and then I doubled it. The time for one half of the straightaway for car X is 1/3 D divided by VC. So you got to double that. That is, this is the time to get up to 2 VC, and then there's another 1/3 D divided by VC. So 2/3 D divided by VC is the entire time to get through this straightaway. Well, that happens twice because there are 2 straightaways. So here's the 4/3 D divided by VC plus what we had already figured out. Speed equals distance over time. If average velocity equals displacement over time, then time equals displacement divided by average velocity. So here's the time to get through the 2 turns. Like I said, got to go back to elementary school and do common denominators. 6/3 plus 4/3 is 10/3, or 3 1/3 D divided by VC. That's the time for car X. I did a similar trick for car Y, except I only focused on the first quarter because that's the region of acceleration. All right, so same trick, distance over time equals initial velocity plus final velocity over 2, except now the distance is D divided by 4. So we're going to actually find the time to get through this first quarter of the straightaway. We go from VC up to 2 VC. And like I said, that equals 1/4 D divided by T. What are we going to do here? Multiply both sides by 2, combine like terms? Yeah, so we would end up with 2 divided by 4. That's 1/2. D divided by 2, and then combine like terms, 3 VC. And so the time to get through this first quarter is 1/6 D divided by VC, but we have to do that twice. So that's 1/3 distance divided by VC. 2/6 is 1/3. Then, the time to get through this middle part of the track, we have to do again. So here we go. Time equals D over 2 divided by 2 VC. Time equals distance divided by 4 VC. Did I do that right? I don't know. Anyway, the total time for the straightaway I'm calculating is 7/12 D divided by VC. We got to do that twice. There are 2 straightaways. That's why I'm doubling it. And then we got to add it to the 2 turns. So if I can do my common denominator trick, I get 3/6 D divided by VC. Well, 3/6 is less than 3 1/3, so I think that's the quantitative comparison they were asking for. Here's the quantitative comparison. This is a greater time, 3 1/3 compared to 3 1/6. That's why X loses. All right, so the easy part of the question is, what direction are these forces? And if they ask for the direction of the net force, they're really asking for the direction of the acceleration. So for X, if it's in the first half of the straightaway, it's speeding up. The tires are throwing it forward. If it's in the second half of the straightaway, it's slowing down. So the tires are pulling backwards. If it's going through a turn, the net force is centripetal. Its speed is constant, and so the net force is inwards. For Y, in the middle half of the track, it's not speeding up or slowing down at all. So there is no net force. And, here it's slowing down, speeding up, slowing down. Thanks for watching. See you in the next video.